Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera to Dr. Najla and to all my friends. In this video, I will explain about polymer for 3D printing. First of all, let me introduce myself. My name is Nur Hidayah binti Isaha. I am from section 7. Firstly, I will explain about the introduction of polymer 3D. Polymer 3D or three-dimensional is widely used in medical areas for variety of polymer material characteristic and processing of manufacturing. 3D printing also is highly advisable manufacture because it is able to construct a design with complex geometry and architectures that are impossible with conventional manufacturing process. For an example, tissue scaffold structures fabricated with polyjet and stereolithography printing can achieve hierarchical forms that mimic bond, thereby providing a mechanical and biological means to support tissue regeneration. The process that include in 3D printing is extrusion, resin, and powder fusion, which come up with variety of material selection and supporting design. A bigger design space has offered in 3D polymer printing for improvement of the medical applications. In this slide, we can see the picture of material process and design consideration for medical application that illustrated for a tissue scaffold example. Schematic shown that tissue scaffold has been made from beam-based unique cell with interrelated of the consideration for material, process, and design. In this example, a design strategy for mimicking the hierarchical structure of bone largely drove the need for a suitable printing process and material selection to support the application. To make sure the structural integrity by retaining biocompatibility for promote tissue growth, the chosen of material have been written by a requirement for appropriate stiffness. In the building of the complicated hierarchical truss structure, the formation layer is needed. Next, I will explain about material capabilities. In material capabilities, we divided by two, which are material structure and material properties. In material structure, thermoplastic is frequently used for 3D printing when they are melted, followed by hardening in the extrusion process. For an example, the common plastic that have been used is acrylonitrile butadiene styrene, or we call as ABS, which this plastic improve chemical resistance and encouraging the impact of strength. Besides that, polylactic acid, or we call as PLA, is another thermoplastic that commonly used because PLA have biocompatibility but lower glass transition of temperature. In addition, PLA works well with other printing processes like stereolithography, which allow for the production of more complex component architecture than typically possible with extrusion method. Although stereolithography printing of PLA raises some concern regarding its toxicity since photopolymers are used in the resin solution, which is necessary for the cross-linking of monomers to generate polymers in the presence of UV light. Thus, PLA is biocompatible. The next one is material properties. In material properties, we divided by 4 items, which are toughness, flexible, biocompatible, and conductive. The first one is toughness. The picture is the tensile bar that have closed edge. The 3D printed tensile bar that have closed hatch structure is printed from tough polyurethane. We can see from the picture. Elastomeric polyurethanes are generally forgiving of notches and patterns, according to the result, which support the usage of this material in a variety of design approaches. A metacrylic polymer printed using the resin curing procedure with a tensile strength of 41 MPa and a general elongation up to 50% before breaking was another illustration of the durability for biomedical products. The next one is flexible material. Flexible material have been constructed recently that are beneficial as prosthetics that via scanning and fitting technologies may optimize a certain component of a person or physiology. For an example, in the figure shown, the nose shaping is using a stratesis polyjet printer with Tango Plus flexible material. For your information, the Tango Plus material had a 26 to 28 show a hardness, 0.8 to 1.5 MPa tensile strength, and 2 to 4 kg per centimeter tear resistance while having a feel similar to rubber. Flexible material with printing of flexible polymer may be used for intricate construction like the model of Eiffel Tower. The model distorts at lower temperature, and as the temperature increases to 70 degrees Celsius, the print regains its original form. The temperature are depending on the first initiate of heat actuation that can be initiated by human body heat or devices. This is an example of the nose shaping. The third one is the conductance. Electrical conductance is another material property that is utilized to 3D print organelles that may be used to create and detect tissue analogs. The picture is a suture pad. Fixing nylon fabric to a PLA mold base, pouring and curing skin colored liquid PDMS, putting conductive thread into 3D printed organelle, encasing sensors, adding a fat layer, and cutting the sample are all steps in the formation of a suture pad. Other than that, the mixture of conductive carbon black filler is used to print the chest rookie that can light up the LED light. Last but not least is biocompatibility. Biocompatibility is a necessary material property for printed devices that interact with the body, such as hearing aids and retainers, or are implanted in vivo, such as artificial joints or tissue scaffolds. In general, biocompatibility refers to the need that a substance not cause harm to the body while supporting its intended purpose. The biological testing have been conducted by measuring cell viability using SARS-2 cells that survive. Another testing demonstrated is the growth of tissue scaffold surfaces. The growth is limited compared to other tissue engineering materials. This is the example of biocompatible. Next, I will explain about printing process in 3D printing. In 3D printing, we have three processes. The first one is extrusion. In extrusion process, the material is melted and extruded through a nozzle where it is directed for deposition to form part layers. The fused deposition modeling is commonly used in extrusion process. The substance is fed continuously into the printer as a filament. There are 3 steps in the extrusion process for 3D printing. The first step is extruder body is heated to melt the filament. Then the filament will cool down, and finally the filament have been solidified to form a solid geometry. In this process, the nozzle will be maintained at a certain degree, but it will higher than the melting point of polymer. The performance of the material will be affected by the increment of the nozzle temperature like PEEK and polyetheramide, or we call as a PEI. Okay, in this slide, I will show the video how the fused deposition modeling works. Like I mentioned before, the step of fused deposition modeling is the first step. The extruder body is heated to melt the filament. And then the filament will cool down, and finally the filament will solidify to form a solid geometry. Let me see it again. The material will heated and then will cool down, and finally solidifies to form a solid geometry. We have the final product in solid. The second process is resin curing. Resin 3D printing process is systematically exposed photosensitive monomers to ultraviolet light or other high energy light sources. Stereolithography printing with direct laser writing, one of the UV strategies, consists of a resin tank, a high-intensity light source, and a reflecting mirror to regulate the resin exposure to a laser. Same like extrusion process, the resin curing also have 3 steps. The first step, resin in the tank exposed to the computer control laser. Then the printing platform move vertically for printing the next layer. And after all the layers are printed, the part is washed and cured under ultraviolet light. We will see how it works, how resin curing process works. Let me watch the video. The first, this is the introduction for the resin curing. Okay, like I have mentioned before, the first step is this is the component of the machine. Okay, the first step is the resin in the tank is exposed to computer control laser. After exposure to one layer, the printing platform moves vertically for printing the next layer. You can see in this. Move vertically for printing the next layer. After all the layers are printed, the part is washed and cured under ultraviolet light to strengthen the structure, which provide fine-tuning for specific application. In this video, we can see clearly the process of the resin curing process. Inkjet printing also use the resin curing process that using nozzle. The bulk of the material are placed and a UV laser quickly cures them to form a layer. Using mechanically effective lattice structures, inkjet printing has recently been proven for use in medical applications, with applications spanning from prototype to electronic to bioprinting. The third process is powder fusion. Powder fusion process is a laying down layers of molten or adhered powder to additively create components. There are two common powder fusion techniques, which the first one is selective laser sintering and the second one is binder jetting. I pick is the step that I chosen that I have explained more is the step of selective laser sintering. There are three steps. The first one is a powder stock level to enable fusion of one layer. Once layer is printed, the platform is lowered and then the process is repeated. Binder jetting printing also use powder fusion process, which are this printing will jetted the material powder and change it from an alternative to laser melting. There are few steps in this binder jetting printing. The first step is on the printing platform. Then the binding substance is subsequently injected to create a bound layer. Binder jetting is commonly processed for printing multicolor, multi-material, and functionally graded material. For the next slide, for this slide, I will explain about my application of polymer for 3D printing. The most commonly application that use 3D printing is medical applications. There are three medical applications that use 3D printing. The first one, tissue scaffold. The first one is tissue scaffold. 3D polymer printing has recently gained interest in tissue engineering application where material, process, and design strategies all play a role. Polymeric scaffold was used in tissue engineering to synthesize the organs and to restoring function. Tissue scaffold was created by polyjet printing. There are some benefits that we can observe. The one benefit is tissue scaffold provide personalization to patients and produce structures that are fine-tuned for clinical application. This is the picture of tissue scaffold. The second one is dental implants. For information, there are about 276 million persons throughout the world that suffer from tooth loss and could benefit from new solution for dental implantation. The emergence of 3D printed polymers has provided economic and precise dental implants. So, polylactic acid has been chosen in the making of dental implant because of its characteristics which are resistant against impact and non-toxic. The polymer also have a little surface roughness that can promote biofilm formation that attract harmful bacteria to the implant. So this is a proof that dental implants help the people that have a problem with their tooth loss. And this is the picture of the dental implants. The last one is a safety equipment. The polymer 3D printed has elevated because of the increases of personal protection equipment such as particle filters and masks vastly exceed demand. Polypropylene 3D printed polypropylene has been used to 3D printed particle filter and masks that give alternative resources to help meet demand and avoid supply chain issue. So this is the picture of a safety equipment. This is some reference that I refer to collect the information about the polymer for 3D printing. So as a conclusion, a review of polymer 3D printing for medical application was conducted and highlighted how material, process, and design decision influence application performance. Therefore, necessary all factors when configuring parts. Design strategies enable the direct placement of material to achieve improved performance with configurations such as architect or multi-material structures. So that's all from me, and thank you for watching. I hope with this video, it will be clear and about the polymer for 3D printing. Thank you.